Hey guys, what's the crack? So this is going to be a quick introduction to physics video, okay? And it's just like key things that you need to make sure you're good with from GCSEs. Okay, main thing is what are scalars and vectors, okay? Scalars, you learnt and hopefully memorized in GCSEs. Scalars only have a magnitude. So they have a magnitude only. So magnitude, if you think about earthquakes, like the size of an earthquake. Magnitude is just a fancy way of saying a size. So we're looking at here is saying that they only have numbers. Whereas vectors, what they have is they always have their magnitude and a direction. So the direction could be left, right, up, down, north, east, south, west. It could be saying positive and negative, okay? So what I mean by positive, negative is in physics, conventionally, we always take anything towards the right to be positive numbers and anything going up to be positive numbers. So if I was to say to you, I threw a ball up at 5 meters per second, again, the scalar there is going to be my speed. I threw it up at 5 meters per second, but the vector there is my velocity. So the velocity is me saying I threw it 5 meters per second up. Or you could say 5 meters per second north. Or I could just say positive 5 meters per second because I take up is always positive. However, if you're doing AQA, one of the big changes is you can't write meters per second like this anymore, okay? So we know that 1 over x in your math classes is going to be x to the power of negative 1, right? 1 over x squared is x to the power of negative 2. So if I have a meter per second, what that really is a meter divided by a second. So that's why it becomes ms to the negative 1. So now instead of writing meters per second, you're going to start writing ms to negative 1. Meters per second is going to be ms to negative 1. Okay? Let's say that I walked a distance of 10 meters east. So again, distance was my 10 meters. Only the magnitude matters. But if I was to look at my displacement, that's my vector, my displacement, I just said was 10 meters to the east. But again, because that's going towards the right, I can just say plus 10 meters to the east because that implies going towards the right. Let's say that I was to drop a ball down, okay? Let's say I was to drop a ball down and let's say accelerate it down. Acceleration is a vector. Okay? So if I accelerate it down, let's say accelerate it down just to gravity. For example, if I drop a ball, the only force action on it is gravity pulling that ball down if we are ignoring air resistance, right? So again, I'm dropping a ball, we're going to ignore air resistance. The only force on it is the force due to gravity pulling it down. And we know that force is W equals mg. So G, we know, is always going to be negative 9.81, and it's a negative because it's pulling it down. And again, acceleration was meters per second squared. But again, if we put it over x squared, it's x to the minus 2. So meters per second squared now becomes ms to the negative 2. Okay, other things, again, downwards in my negative because it's going downwards. And I'd highly stress that you learn that number. It does get given to you on your data sheet at the front. We don't want to waste time when you use this number so much in physics, okay? Other ones we need to know about is time is always going to be a scalar. Temperature is always going to be a scalar. Other things that are scalars is mass, measured in kilograms, is always going to be a scalar. Things that are vectors that you know about is forces are always a vector. So again, let's say I put a force of 50 newtons towards the left. I can't say saying 50 newtons towards the left. I can say negative 50 newtons because the negative tells me it's going towards the left. Other things you need to know about is momentum. And again, momentum, we know the equation for momentum is equal to mass, P equals mv. Momentum is mass times velocity. So it's going to be kilograms meters per second to the negative 1. Okay? Again, other ones we need to know here especially is energy. Energy is a scalar, always measured in joules, and it doesn't matter about the direction when you quote your answers. Okay? Okay, what's then important is just make sure we're good about visualizing these things. So let's say my house is here, and let's say I get in my car, I leave my house, and I go towards the shop. Let's say the shop is 2 miles away. I then come back towards my house. If I was to draw my displacement time graph, the displacement is just going to end up 0, right? All I did is I ended up back where I started. So again, we went towards the right, so I'm going in the positive direction. So my displacement is increasing over time, and then it's coming back to where I started. Okay? So what you can see here is that the gradient of these lines always tells us about the velocity. So we're going to assume it's a constant velocity. So I get positive numbers for velocity when I travel away from my house, because I'm going towards the right. I'll get negative numbers for velocity because I'm going back towards my house. But let's say instead of going back towards my house, let's say that I went to the shop that was my 2 miles away. And instead of going back to my house, I went to my friend's house. And my friend's house, let's say, is 1 mile away from my house. If I was to draw my displacement time graph, again, I went away from my house, so it's going to be positive velocities, back towards my house, my negative velocities. But then I didn't end up back where I started of a displacement 0. We kept going to the other person's house at the same velocity. So we're going to end up with a negative displacement. We end up further away towards the left of where we started. That's why we get a negative displacement. Okay? So you just need to make sure you're okay with what vectors and scalars are, and that negative doesn't imply super slow, right? For example, if I'm going to speed, like we said before, if we said we got a speed of -5 meters per second, that doesn't mean that it's a really, really tiny number. It means it's got a speed of 5 in the direction of the left. Because remember, the smallest speed is 0, that's stationary. So any negative numbers don't mean there's tiny, really small numbers. It means that you're going in the opposite direction. So -5 meters per second is the same speed as +5 meters per second. The only difference is the negative and positive tells us about the velocity, what direction it is. So a car going towards the left at 5 meters per second, or a car going toward the right at 5 meters per second. So if you find the video useful, just remember you can check out our online lessons at the myadspace.co.uk website.